Welcome. Today we're going to demystify a fundamental lab procedure that actually affects the water you use, every single day. We're going to break down exactly how professionals measure something called water hardness. You know there's something you can't see, but trust me, it's there. It can build up in your pipes, it can affect how well your soap lathers, and it's hiding in your tap water right now. And in this explainer, we're going to learn exactly how to measure it. All right, let's dive right in. Before we can even think about measuring it, we have to know what we're looking for. So what is water hardness anyway? Okay, don't let the big words fool you. It sounds super complicated, but in simple terms, it's just the amount of dissolved minerals in the water. We're talking specifically calcium and magnesium ions. Just think of them as tiny, invisible bits of rock floating around in your water. So why should you care? Well, this isn't just some abstract science problem. That scaling is the chalky gunk you see in your kettle, and it forces your appliances to work way harder, using more energy. It also makes it so much harder for soap to lather up. And for industries, oh man, managing hardness is a constant battle to stop their expensive equipment from getting ruined. So how on earth do we find these invisible culprits, these calcium and magnesium ions? Well, we basically call in a chemical detective to hunt them down. And our special agent is a chemical called EDTA. In a lab process called titration, we add this EDTA to our water sample. Its one job, its only job, is to find and grab onto all of those hardness ions. This is the gotcha moment. See, we add a special indicator that turns the water a wine red color as long as those hardness ions are floating around free. But as our EDTA detective starts grabbing them all, something amazing happens. The second the very last ion is caught, the water instantly flips to this really distinct blue. That color change is our signal that the job is done. So, we get a color change. Big deal, right? Well, it is a big deal, because here's the crucial part. We can turn that visual change into a hard number. And to do that, we use a surprisingly simple formula. Now, I know, this might look a little intimidating at first glance, but I promise you, it's way easier than it looks once you know what each part means. So let's just break down this puzzle piece by piece. First up, we've got A. A is just the amount of our EDTA solution, our detective, that we had to add to the water to get that color to flip from red to blue. Super simple. We measure it in milliliters. Next is B. I like to think of this as the capture power of our detective. It's a value we already know, and it tells us exactly how much hardness just 1 milliliter of our EDTA solution can find and grab onto. And finally, we have the easiest one of all. ml sample. This is just how much of the original water we started our test with, again, measured in milliliters. So, let's put it all together. We're multiplying the amount of detective we used by its capture power. Then, we divide all that by the size of our water sample. And that 1,000, that's just a little helper to make sure our final answer is in the right units. See? Not so bad. Okay, enough theory. Let's put this formula into action and see how it works with a real-world example straight from the lab. All right, picture this. A lab tech just finished their titration. Here's the data they're looking at. They found that it took 12.5 milliliters of EDTA to get that color change. They know their EDTA's strength factor is 1.02, and they started with a 100 milliliter water sample. We have everything we need to solve this. Now for the fun part. We literally just take our numbers and plug them right into the formula we just learned. A becomes 12.5, B becomes 1.02, and our sample volume on the bottom is 100. So first things first, let's tackle the top part of that equation. We're going to multiply 12.5 times 1.02 and then multiply that by 1,000. And that gives us 12,750. Almost there. For the final step, we take that big number, 12,750, and we divide it by our sample volume, which was 100 milliliters. And that gives us our answer. And boom, there it is. The total hardness of this water sample is 127.5 milligrams per liter. We've officially turned a simple color change into a precise scientific measurement. Pretty cool, right? But what does a number like 127.5 actually mean? Is that a lot? Is it a little? Let's find out what this number is really telling us. And honestly, this is the whole point of the entire process. A number by itself is pretty useless if you don't know how to interpret it. We need to connect this calculation back to the real world.
Okay, so if we pull up a standard classification chart, we can see exactly where our result of 127.5 fits in. We just scan down the list, and there it is. It falls smack dab in the hard water category. So yes, our sample is definitely hard water.
And knowing that, well, that's everything. For water treatment professionals and engineers, this isn't just a classification, it's a call to action. They now know that water softening processes might be needed to protect all the pipes and equipment from that damaging scale buildup. So there you have it. You've just mastered the calculation. That's the first absolutely essential step in tackling one of the most common challenges with water. But of course, knowing it's there just leads to the next big question, doesn't it? What do you do about it?